Population, sample, parameter, and statistic. These four terms are going to be very important as we make our way through this course. So it's important to understand what they are now, as we will be using these terms as if they are just part of our everyday language when we get to the second half of the course. So let's take a look at these definitions that are given. First, a population just represents all the data that we are interested in considering, versus a sample is a subcollection or sum of the members from that population. So you'll see for the population, if we were to look at what this looks like, it would be a list. We would have a list of every single data point in some variable. Whereas a sample, that's also going to be a list. However, it's not going to be the full list. It's only going to be some of the things that were on the list that we selected. One small little detail here is that the word census is the act of collecting all of the data from our population. If we were to just select some of the data, we call that, again, a sample. So how is this different from a parameter and a statistic? You'll notice that the parameter kind of lines up with population, plus the letter P's kind of go together. Same thing with statistic, we have it lined up with the sample and the letter S goes together. What do these things do? A parameter and a statistic are both measurable characteristics. It's some kind of measurement. So the only difference between them is who are we measuring? Are we measuring the entire population of everyone we're interested in? Or are we measuring just the certain people that we collected from our sample? So when we have everyone, we call it a parameter. When we have some people, we call it a statistic. Now notice that these are measurable characteristics, so it's just a measurable number, a single number or single value. So that's one big thing that we can see is the difference between a population and a parameter. A population will look like a list of all the responses to some survey question or the list of all of the values of some variable. Versus a parameter is if we take all those values and measure it in some way, we get a parameter. Same thing with sample and statistic. A sample is a list of all the people that we actually surveyed or a list of all of the values that we actually collected. Versus a statistic is just a single number that measures that entire list. So let's look at an example of this. Suppose we have 5 clients at a fitness club and they were randomly selected and surveyed where we asked them their target number of calories that they try to eat each day. And maybe we're interested in what is that average number of calories that these clients in the club target each day. Well, here we see we have a list. I have the list of every single client at the club and how many calories they will target. So one person said, oh, I'm trying to eat 1,500 calories. Another said 2,200, and so on. And this ... just means that this list goes on and on and on because there are a lot of people that work out at this fitness club. So now, if we were to take all of these numbers and only select 5 of them, 1, 2, then 3, 4, and 5 from the rest of this list. Well, what do we get here is another list. We have just 5 on here, and it's the 5 that we selected, so only some of this entire group. So what do those 5 represent? That would be our sample, versus over here where it's everyone would be our population. So when we have a list of everyone, we call it a population. Notice it's a list of values. And then also on the right side, we have our sample, since it's only some of the entire population. Now, one thing about this is, even though we have these lists, sometimes when we refer to the population, we're not only just referring to the measurements themselves or the values themselves, but sometimes we just refer to all the clients at the club, and we'll say this is our population. And it is fine to do that. Same thing with sample. This is our sample, which is all of the values that we randomly selected, or we can just refer to our sample as the 5 random clients selected. Now that we have population and sample, what does parameter and statistic look like? Well, if we were to take all these values and let's say calculate the average, well, this average would be a single number measurement that summarizes this entire list. And so a parameter, one example we have is the average itself is a parameter where we take every single value in this list of all clients at the club and we get some average, like 1,796.2 calories. On the other hand, if we were to do the same thing, just take these 5 values and find the average of only those 5, then we could call that one a statistic. Now notice, both of them are averages because they're both measurements. It's just who are we measuring? For the parameter, we're measuring all of the clients, our population. For a statistic, we're measuring just the 5 random clients. So let's summarize that example. If we were to put this in words as if this was a test question, the population in that group would have been the target calories for all clients in the fitness club. Or as I said earlier, you can just say all the clients at the fitness club. Our sample would be the list of target calories for just the 5 randomly selected clients. Or as I said before, you can just say the 5 randomly selected clients at the fitness club. Our parameter, again, is the measurement of the population. So the measurement would be, in this case, an average of the target number of calories for each of the clients. So notice it's for all of the clients. Versus a statistic would be the average target calories for just the sample, the 5 randomly selected clients. Let's look at one more example. Here it says, we want to know what proportion of California will be voting for Mr. Lewis in the next election. We call 50 random numbers in California and ask, are you planning on voting for Mr. Lewis in the next election? So let's think about what that population, sample, parameter, and statistic would look like. Take a few seconds and see if you can write that down. Then look at the next slide for the answers. Pause this video if you need to. All right, so now let's take a look at those answers. The population in this case would be the votes for all voters in the next elections. So if you just said the voters, all the voters in the next election, that would be fine. However, if we thought about it, we would actually have how they voted, their actual votes, if I were to list it out. Same thing with the sample. If you just said the 50 random voters who we called, then that would be fine. But if you think about it, again, our list of how they voted, whether it was for Mr. Lewis or not, that would be our sample. The parameter was listed up here that we're interested in. We want to know what proportion or percentage of California are actually voting for Mr. Lewis. So that's the single number, the single value measurement that we're interested in. So here our proportion of all voters, since it's out of everyone who are voting for Mr. Lewis, that would be our parameter. Same thing for statistic, it's the proportion who will vote for Mr. Lewis, but out of who? It's out of only our sample, out of the 50 random voters that we called.